The fourth topic in the third unit is common source amplifier. Common source amplifier is one of the three basic single stage field effect transistor amplifier topologies, typically used as a voltage or transconductance amplifier. The easiest way to tell FET is a common source, common drain or common gate is to examine where the signal enters and leaves. Common source amplifier input signal is applied at the gate terminal and the source terminal. The output is amplified and obtained across the resistor at the load in the drain terminal. This is called as common source amplifier. Here, source acts as a common terminal between the input and output. It is also known as voltage amplifier or transconductance amplifier. It produces current gain and voltage gain according to the input impedance and output impedance. To produce voltage gain along with high input impedance, FETs are used in these type of circuits. In common source amplifier, the circuit diagram is N-channel FET along with the coupling and biasing capacity. The circuit will similar to the common emitter follower in the case of bipolar junction transistor. If we use P-channel FET, the polarity of the input voltage will be just reversed. This circuit diagram represents common source amplifier. Here, the source terminal is common to gate as well as drain terminals. Here, the source is nothing but the majority of the source of carriers required for the device enters through this terminal. Through a source terminal, current enters the channel, which is denoted by S. Drain is the majority of the carriers in the channel leaves through this terminal, that is draining. Hence, conventional current enters the channel, which is denoted by ID. Gate terminal. This terminal always controls the conductivity of the channel. Hence, the flow of current in the output is controlled with the help of a voltage level across the gate. Common source amplifier. Here, there are two capacitors are normally used. The use of this capacitor is to check whether the gate terminal is affected by any DC voltage of the previous stage. The resistor R2 around 1 mega ohm is connected between gate and ground, which holds the potential. The voltage is developed across the resistor R2 that holds the source above the ground. The bypass capacitor C2 is provided additional gain for the signal. The amplified output voltage is coupled to the AC signal of the next stage by the capacitor C3 by blocking or eliminating DC components. Applications of common source amplifier, which is normally used in amplification of sensor signals, low noise amplification of RF signals, communication systems like TV and FM receivers, voltage control devices in op-amps, which is also used as cascade amplifiers and RF amplifier circuits.